So this video is going to be a follow-up to the last video where I did the in-depth teardown of a Breville Bambino, and this video I'm going to focus on the electronics of that machine. And so you'll see in front of you I have an annotated photo of the PCB, and we're going to walk through this in quite extreme detail. Now, this photo I have uploaded onto the GitHub, and it's a stitched together macro image, and so you can scroll in and get quite good detail on all of the components that are on this PCB, and I've, again, labeled them to the best of my ability. In addition, I've also uploaded a photo of the back of the PCB so that you can see all of the traces on the back side. And finally, I've also updated my version of the schematic of this board. And this schematic goes into as much detail as I could get. I've traced everything to the best of my ability. I've labeled all the components. And it has quite a few of the component values, but I don't have everything nailed down because, measuring capacitors while they're mounted in a circuit isn't very reliable. And a lot of the SMD components, I didn't bother to actually check, and without pulling them off the PCB, you're not really sure what you've got anyway. But the first place we're going to start off is actually just by looking at the hardware wiring, and then we're going to come back and look at the PCB. All right, so we're going to look at the wiring of the hardware, and let's start off with the mains. So coming in through the plug. All right, so we got the ground. Let's just check everything just to make sure. Flipping the old multimeter over to continuity, and we should see between our ground lug and anything we want to check, like up here, this should be ground. It is, so that works. So the power will come into the main board through these two wires from your plug. So the brown is going to be the line and the white is going to be the neutral. And so to map that onto the plug, just so you'll know which is which, again, the brown should be the line. So let's see, is that going to be this one? Nope. Okay. So looking at the plug, the larger, this tends to be in the United States at least, this would be the larger ear, and that actually maps to the neutral. And then the smaller, that is going to be what's called the line, and that's the brown. Okay, and so that's where those map into the board. You'll see two plugs here. You'll see one with an N and one with an L, again, for line and neutral. Again, brown's line, white's neutral. Okay, with that out of the way, let's look at the wiring. So let's start off, I'm going to just not even worry about the flow meter because it's low voltage. I'm just going to look at the high voltage stuff, the mains stuff. So coming from the board, we have this blue large thick wire. So this is basically going to be like a common neutral for the pump, for the solenoid, and for the heater. And so the way the connections run, this blue comes into a little split here. So the lighter blue goes up to the heater, the thicker blue comes to the pump, and then it has another little split where the other blue goes up to the solenoid. So this is basically going to be a common neutral for all of those AC systems. So starting with the pump, if we pull its wires around, it's going to be controlled and switched from the board via this orange cable here. And so it will basically be the main connection. Now it's connected, it may be hard to see. On the side, pull these wires out of the way, you'll see this kind of thick orange wire, and it is crimped onto another yellow wire, and there's some blob there, and that's basically going to be like a thermal fuse on the side of the pump, just in case your pump overheats, that it will start to reduce current flowing through that system. So the orange wire, that's going to be the one that controls your pump. For the solenoid, again, it's got that common blue. It's also got a big green wire for a ground connection, and then it has the yellow wire, and this is basically going to be the line side where the board will control your solenoid through this yellow wire. Moving on, now we get to the more complicated system, which is how the heater works. So remember that the heater is going to have a return for AC power through this blue wire. And so basically what you need is the other side of the AC leg being controlled. And so that's what the triac back here is going to do. Now going to the triac, there are 3 wires. Pull these out. There's purple, there's white, and there's red. And so here's what these things do. The purple wire is basically the feeder line, right? So if you're wondering, the main circuit for the heater is from the purple and blue wires, right? And again, it's AC, so if you want to call the blue the neutral and this being the line on that, fine. The triac is going to be controlled or switched by the white wire. And then this red, best I can tell, is more of a sense voltage so that the board knows when there's power and when there's not going through the triac, because it's coming from a crimp and one side of the red wires go to the triac, the other goes through the heater. So basically, power goes into the triac, it will be switched by the white wire, and then it's coming out the red wire to go up through the heater, which then returns back through the blue. And so that's what controls the heater. It's got 4 wires, but I believe this red one's just to sense whether current's flowing. The real current's going to be carried by the purple and the blue wires, and the switching on the triac is going to be controlled by this white wire for the signal. The only other wires up here, we've got a ground going up to the heater, and then we have this brown wire coming down. And so this brown wire is from the eFast system, and when the heater gets too hot, the resistive mask on the heater element itself will start to conduct, and this will produce some voltage, and I'm guessing just regular AC with low current, I would assume, that will be fed back into the board's power circuitry. And so that returns back into the board here, and I'm not exactly sure how all this section of the circuit works. I do know that there's like some 555 timers down here, there's voltage detectors down here, there's transistors down here, and then there's a little optocoupler here. So I don't know if all of this is simply to produce a signal that the microcontroller understands that the eFast is sending a signal and saying, hey, this thing's too hot, or if it has some more electrical control over, again, something in this power structure. But again, I don't think anything up here will affect power running to your heater because, again, it's basically got AC already wired in that's only being controlled basically through that white control wire. And again, it's being sensed and picked up here, but there's no real power circuitry running through that return feeder. So I can only imagine that eFast is just some sort of detector system that's being fed back to the MCU. That's really all I can imagine. And so there's your general overview of the main wiring for the major components inside this system. Okay, so let's dig into the PCB. So the main power comes in over here on the bottom left. You can see the brown wire comes in, that's the line. The neutral is going to be the white wire. You've also got a varistor and a big capacitor and these 3 little resistors here. Those are all between the line and the neutral. You can see this also is on the schematic. I basically built the schematic to kind of physically be oriented similarly to how the PCB is. I did this mostly for my own benefit as I was trying to trace everything out, so to give me a little bit of a visual orientation reference to spot components that I'd missed or where everything was. So here you can see the value for that varistor. You've got a 1 microfarad cap, and then I actually was able to pull resistor values off of the components here in between the line and the neutral. So these basically form power rails for a lot of the mains voltage devices that are inside of the Bambino. And you can see some control circuitry pulling in from the microcontroller. You've got a bank of opto isolators feeding into the control circuitry for the power for like your solenoid here, the pump, and the main control for the heater. So the microcontroller is basically using these opto-isolator relays to switch the solenoid and the pump on and off. And so those opto-isolators, those relays, are basically working as switches to turn on and off a couple of triacs. And so here you can see these JST02Ks. And so these triacs are basically leading out to the solenoid and the pump through these tabs, and that's going to be labeled with the yellow and orange wires. So that's going to be this big section here with the big yellow capacitors, and here you can see the two triacs mounted on the board. You can see that they are mounted to this big power rail that is coming from the line or the brown mains connection here. So you've got your spade terminals, these big spade terminals for the orange and the yellow wire. You also have the main heater connection here. But now the heater wiring works a little differently because as you can see, there's no triac here. The triac is actually mounted off this PCB on another external PCB. And so if I go over to the page for this hardware, you'll see here I have the schematic for the mini PCB where the off-board triac for the main heater is. So you've got these tabs on the main PCB. Tab 3, tab 10, tab 9, that is going to be the purple wire, the white wire, and the red wire. So that comes in to this off-board PCB through the triac. There's also a resistor, a 1K resistor, and a little capacitor just for the control circuitry. So that white wire is going to be the control wire. So you've got the line coming in here, and then this red tab, to the best of my knowledge, this is some sort of external feedback. That red wire is coming in right here, and it is being fed by line voltage, but I believe this is some sort of reference point that's being used for the control, because you can see the MOSFET white wire coming out here. And so essentially there's a little relay in here that's being turned on and off that turns the triac on and off. And I think the way this thing works on this hardware side is basically it does need this resistor and capacitor to make kind of the triac work. So anyway, out of the triac, you've got the mini melt that's mounted up on the heater itself, and then that runs through your main heater, the FTH2, which is a 1500 watt. And so coming out of the other side of the heater, that ties in back to the neutral, which if I go back to the front over here, the blue wire connecting down here straight to the neutral mains voltage. And so basically you've just got your switching network here for all of the main components. Now, in addition, you also have a couple of other kind of opto-isolators here. Now, I'm not exactly sure what these are being used for. I think there's some sort of voltage sense. They do go back to the microcontroller, and so I think maybe this is just a way for the microcontroller to be able to pick up the mains voltage that's happening over here on the switching side. I'm not 100% sure exactly what's going on, but I can tell you they do feed back into the microcontroller, and on the MCU control sheet, I do have these mapped in to where they go. So the next section I'm going to look through is the power supply. Now this is quite complicated, and I'll just be right up front that I'm not 100% sure what all is happening in the power supply circuitry. The main inputs come in on the bottom of the PCB. So if I scroll down, you'll see over here you've got a fuse and a big 5 watt 18 ohm resistor here. And a little, what I've got labeled as a transformer, it's not really a transformer. This is really more of like a dual inductor going into a bridge rectifier with a large output capacitor. So I've got that labeled down here on the bottom. You'll see this kind of coupled inductor. You've got your big 3.15 amp fuse here and that 18 ohm resistor. Here is the diode bridge. It's an LMB8S. And then the big output capacitor, this 33 microfarad, labeled as C7. I also, by the way, did try to keep all of the PCB labels as I labeled all the components, just for reference in case you're ever double checking anything. Coming out of this big capacitor, there's just a whole bunch of stuff that happens over in the power supply. So you've got a big transformer here. This thing has 4 windings that I could find. I couldn't really figure out any specs on the transformer, but it looks like some sort of switching mode power supply, I think. You've got a flyback regulator over here. You've got your output windings coming out and feeding into the low voltage power supply. But then, in addition, you have this whole subsection down at the bottom, which I think is part of the EFAS system. Now, I'm not exactly sure how it works, and I don't know what everything down here is for. There's a variety of diodes and NPN transistors. There's a 555 timer. There's a couple of voltage detectors. And out of that, that feeds back over through a photocoupler into the low voltage side where the microcontroller can sense, I think, if voltage is being picked up on that EFAS lug. So if I go back into the schematic and I look at the hardware here, there's a terminal on the heater for this EFAS connection, and whenever everything's working normally, that's not connected. And what happens is the heater, if it gets too hot, the actual surface where the PCB heater is printed will actually start to conduct, I believe, to this EFAST pin, which comes in through tab 8 into the PCB. So that is this tab right here. You'll see tab 8. So basically, if the heater gets too hot, I believe this will start picking up mains voltage. Now, I guess everything else here will work to sense that voltage and maybe notify the microcontroller that there's an over temperature event going on. But I'm not exactly sure. I mean, this stuff also ties back into the transformer. If we look into the power supply, you've got that EFAS lug coming in. It does kind of tie into the neutral over here, but it also feeds back up into the transformer network. You know, this flyback controller is also kind of, it eventually ties into all this stuff. So I'm just frankly not sure what's going on. If anybody has a better understanding of either that EFAS system or how this power supply is working, feel free to comment and let me know. So I can tell you that on the upper side of the schematic, essentially the output of all these, you get a negative and a positive rail for your low voltage. So this comes in, you've got a couple of capacitors, and then this positive voltage becomes what I'm calling VDC. That feeds into, if I come over here to the PCB, there's a little buck converter, this TPS 56200, and that kicks down the main DC output voltage to a more regulated lower voltage that the STM32 runs on. So that's going to be like a 3.3 volt. And I think, I believe coming out of here, if I remember correctly, the main VDC coming out is going to be like a 5-volt rail. And so that's basically the entirety of the low voltage power supply. Now the big capacitor here, the C28, you can see that's this big Rubicon. The little capacitor under it is the other one on the schematic, this C33. You also do have a couple of big safety capacitors. Again, it's a pretty complicated circuit for the power supply that I really don't understand, so I'm not going to go into that in too much detail. So next up, let's look at the microcontroller, and this is where a lot more interesting stuff happens. So I've got the main microcontroller laid out here. It's an STM32F07. So I've got the power circuit coming in through the top side, and let's kind of look at the microcontroller layout. So first off, let's talk about the input control. So I've got this connector over here, this 1x9, and on the PCB, this is going to be in the lower right, so this front panel plug, and so I've got that thing laid out here. So the first 3 pins are all going to be power. So it's going to have a VDC, which is the higher DC voltage. It's got the VDD, which is the lower DC voltage, and a ground connection. It also has pins because on the front of the machine there's the 4 buttons, so it's got a pin for each button and a pin for each LED. There's actually 2 buttons that light up, and so that all runs to the front control panel. Now I've actually put the front control panel layout on the hardware tab here, and so you see, okay, these pins come in, and then what happens? Well, you've got your buttons, right? So each one of them basically just goes straight to the connector, and the buttons then connect to VDD. And again, this is signaling back to the main microcontroller, so they're going to work off of the same voltage as the microcontroller. Now, the reason you've got the higher voltage is because that's what's going to run your LEDs. So the signal for each LED comes from the microcontroller, and then it's actually switching the LEDs using these little NPN transistors. And so you can see each LED is actually two LEDs. They're mounted one on top and one on bottom of each button that has little light pipes around it. And so you've got these two little transistors that are handling the switching. And again, that's what these two pins on the connector are feeding into and handling the switching for those LEDs. So on this connector, these pins for the buttons themselves, they don't come straight into the microcontroller. There is a little resistor network for each pin coming out of the buttons. So they come over here and then they will feed back into the microcontroller all in a little section, but each one does have its own little voltage divider and capacitor on the board. Again, I guess they're just being very careful so that, you know, if any voltage, I guess, hits one of those pins or the wire gets shorted or something like that, there's a little bit of protection, I guess, for the microcontroller before it hits and burns up anything. So one last thing about the buttons on the front panel with this header. There are also some connections through some diodes that I think is also just some sort of feedback for the microcontroller to tell if a button's been pushed. So up here, I've got the circuit. So you can see there's this pin 2 that goes to the microcontroller. And then each one of the connections from a button comes through a BAT54C, which is like a Schottky double diode thing. And I'm not, again, exactly sure what's going on with this, but I think it's just some way to let the microcontroller monitor whether or not a button has been pushed. Again, not sure why this is necessary if you also have the connections for all the other buttons, but again, if anybody has more understanding of how these things work, maybe you can let me know. Most of the switch circuitry, and so you'll see the resistor network and capacitor for each button is down here. You'll see the double BAT54s. So all of the stuff for the front panel is essentially down here in this area of the PCB. So next up, let's talk about the thermistor. So this blue connector actually goes off, and there's that NTC thermistor mounted on the heater. So that feeds in through this plug. Up here at the top, you'll see the plug comes in. One side is connected to VDD. Again, the sensor here is running on the same voltage as the microcontroller. The signal comes in and is fed out here. So I'm not exactly sure what all this is for. Now I know with some of this, it's going to be a bit of a voltage divider network, because the way this thermistor works is it basically changes its resistance to heat. So I know that that's part of it. And so you do have some diodes here with voltage between VDD and ground. And then essentially probably a voltage divider here, but I'm not exactly sure what pin 19 and the NTC signal are both for exactly. I do have them labeled and what pin they connect to, but I'm not exactly sure why there's two of them. Again, my experience with an NTC is you really just need one signal with the voltage divider, but they may have some other types of protection for the microcontroller built in here. I'm not exactly sure. If anybody knows, again, this would be a nice comment to have if anybody actually knows what's going on here. But that is basically the circuitry for the NTC thermistor. I also point out here on the left side of the microcontroller, there is a 8 megahertz crystal, external crystal reference for this. It's also got a little bit of memory down here, the BL24C64EE PROM chip. I do have that circuitry also here. So here's the oscillator, 8 megahertz oscillator. And the memory chip is actually quite simple. There's a little serial clock and data pin. Couple of the connections go to ground, and half of the pins on that chip aren't connected to anything. So really not a lot going on there. So next up, let's look at the flow meters that comes through this big white connector, this con 3 here. So here you'll see con 3 for the flow meter. Now the middle pin's just a ground connection, and then you've got pins 1 and 2. So the pin 1 is going to be power to the flow meter, but that's actually going to be controlled by, again, a couple of transistors, and there's basically going to be a power enable pin that turns these on so that power can flow to the flow meter. The signal coming back is going to be a square wave signal. It comes through yet another transistor, and then there's a little voltage divider, and then it goes out to a flow signal pin on the microcontroller. So you'll see over here the flow signal pin and the flow enable pin labeled over here on the schematic. Now, also in this area of the PCB, you see these two PCON and TCON connectors. These are unused by the machine. I believe PCON is going to be a programming connector, and I think T might be either a test or something like that. I've actually broken these out. And so in the middle of this page, you'll see the PCON and the TCON. So this TCON has voltage and ground, and then pins 30 and 31. Again, I don't know what else is going on. This just may be something to communicate. It may be serial communication or something. I'm not really sure. But there's only 2 pins connected to the MCU here. Now, the PCON, I think, is going to be some sort of programming, and so it has a connection that goes to the in reset pin, and so it seems to have kind of a serial wire debug connection, right? So it's got a clock and a digital input-output pin, and this does seem to be basically, if you've used any STM32, they have this serial wire debug, and I think that's what this is. So I think you could reprogram this chip through this connector if you wanted. Now, the component here, best I can tell, is some sort of a voltage detector, and I think this has something to do with maybe an auto reset for the chip in case something goes off with the power supply. I'm not exactly sure because I'm not overly familiar with how the serial wire interface kind of works. But this may be some sort of system, again, I'm guessing for some sort of voltage protection or something on the programming system. So the last thing we'll talk about is the control of the mains voltage devices. So you'll see these 3 transistors are all basically the same. Each one of them comes from a different pin on the microcontroller, and each one goes out to a different opto isolator. And this is basically what's switching those things. So let's say the microcontroller sends a signal out for the pump to turn it on. That comes through the transistor, and then that goes out to the opto isolator and flips it on so that it can turn the pump on. The same thing basically works for the solenoid. And for the main heater, again, this is going off and then turning on that triac through that external PCB. And so that basically covers how everything is controlled by the main microcontroller. There is also that last kind of opto isolator that I was saying, hey, there's a couple of other things over there that I'm not exactly sure what they do. I do have everything labeled to the best of my ability on here. So again, I'm not sure what they do, but I do believe the circuit that I've got laid out is correct. So again, if anybody knows what's going on with any of that, please let me know. Now, the last page here is, again, just the hardware, and I've already covered the heater a little bit. You'll see also the power for like the solenoid and for the pump comes from the tabs on the PCB that I've already labeled. And so basically, the line voltage comes in out of the PCB. For the pump, it does have a little thermal cutout on it. I think there's just a thermal fuse. It looks like it's just glued or epoxied to the side of the pump. Maybe silicone. I didn't actually check, to be honest. I've got the Oka pump here, and then the solenoid, and then those feed back into the neutral through their blue wires. And so that's really it. I know it may seem a little bland for people that aren't interested in this stuff, but in case you're curious, this is how you actually control these things. And, I'm sure as far as anybody who's working on some sort of project to DIY an espresso machine build, there is the what is it called, the Gagguinio or whatever project Gagguinio, where people are using Arduinos and stuff to control espresso machines. This might be a handy reference, looking and seeing how Breville does it, because if nothing else, you can basically be sure that if Breville is using a method, it is pretty safe to use. They know what they're doing. They build a lot of appliances. They've got a lot of budget dedicated to this stuff. So I'd say this is a pretty good example of a very high quality circuit, I would believe, to control an espresso machine. Again, I would expect not a lot of corners cut with the design here. You can see different things they've done. So they've got big cutouts on this PCB, hard cutouts between low voltage and high voltage stuff. If you'll notice, all of the high voltage is here. You've got the opto isolators. Each one of these, if I look at the bottom of the PCB, there are cuts between the low voltage side and the high voltage side. So the high voltage stuff is all here. You've got the power supply in the middle. And then over here, you've got ground plane and everything for the low voltage stuff. Everything seems to be well thought out and designed. It's organized pretty well. Shooting this thing out and trying to figure out where everything went. The power supply section was kind of a pain in the butt, but to be honest, the high voltage stuff was really easy, and the microcontroller and all that layout was fairly easy because everything's pretty much laid out in blocks. Everything's grouped together fairly well, and so it wasn't too hard to trace a lot of this out. It took a little bit of work, don't get me wrong. I spent hours on it, but it wasn't impossible. So, that said, that's going to wrap it up for this video. I'd love to hear back from anybody who really knows more about what's going on in the power supply or with this EFAS system, because that's the one area where I really wasn't sure what the heck was going on. But otherwise, that's it for me. I hope that you found the video informative, if not overly interesting. And if you got any feedback or comments, feel free to leave them down below.